Welcome back to the plenary. It's great to see you all here. We've got a very exciting session coming up about advanced materials being used to cut our industrial edge. And without any further ado, let me introduce you to the moderator for this panel, contributing significantly, I'm sure, as well, Marc Lamette.
Hi again. A very, very good morning, everyone. It's really a great pleasure to be here with you all on the second day of the R&I Days 2024, which I sense is shaping up to be at least as rich as yesterday. Materials have shaped civilization ever since the Stone Age. And advanced materials, with what I call their magic properties, are a key enabling technology present in our daily lives, much more than we know, probably. Renewable energy, LED lighting, depend on advanced materials. Actually, 70% of energy innovation is based on advanced or new materials. Without advanced materials, computers and artificial intelligence would not be as performing as they are today. We celebrate the 40th anniversary of the R&I Framework Program this year, and advanced materials are part of the success story. We are world leading in material science. But the question is, do we turn this leadership into an advantage for the competitiveness of European industries? I would say not as much as we could, and that must change. Our new strategy on advanced materials for industrial leadership, which we just put forward a couple of weeks ago, sets out a comprehensive and compelling agenda to get to that leadership. It is about, first, creating a dynamic, secure, and inclusive ecosystem for advanced materials in Europe. Second, aligning our R&I around agreed objectives and priorities. Third, increasing public and private investments. Fourth, strengthening the demand side. And last but not least, attracting and training the best talents. This is what we will be exploring now with three distinguished speakers who will share their experience with us all and contribute, I'm quite hopeful, very concretely to this journey. So it's a great pleasure for me to welcome on the central stage Professor Clivia Sotomayor Torres, Director General of the International Iberian Nanotechnology Laboratory in Braga, Portugal. You may applaud. Also, Dr. Luc Langer, Managing Director of Materia Nova, an R&D center in Mons, Belgium. And we also have joining us remotely Dr. Sabine Klauke, who is Chief Technology Officer of Airbus. Hello, Sabine. Thank you all very much for your availability to be here with us today. And I would like to start with you, Luc, who will offer us a testimonial on your experience with the framework program. Luc, one of the main objectives of the EU's advanced materials strategy is to facilitate industrial uptake. This represents actually a key activity of Materia Nova, scaling up of materials innovation. So can you highlight successful examples of European projects, and did the European R&I framework program make a difference in advanced materials?
I will try. Thank you to having invited me here today. And indeed, I will try to explain a bit what we are doing in research project concerning advanced materials. And knowing that Sabine is with us, I have chosen one example coming from the aeronautic industry. And to illustrate a bit the role of a research center like us in the process of development and innovation in advanced materials. The project I'm focusing on now was called Stellar. It was in the Clean Sky program, and was focusing on how can we reduce the CO2 emissions of planes. So Airbus developed, and Sabine will correct me if I say something wrong, developed nice, smooth surfaces, optimized surfaces, which laminar flow around the wings, which allows to reduce the friction coefficient of the plane, and therefore reduce the consumption of kerosene and reduce the CO2 emissions. One issue and one challenge is that these surfaces are so optimized that they are nearly perfect surfaces, but they have to be protected in time. These nice properties have to stay available over time in real life. So the objective of the project was how can we develop a surface treatment or coating which will protect this surface over time. In that consortium we had really academic scientists really understanding each small parameter we can tune in materials to change properties of the materials. And on the other side, we had industrial partners who are producing real parts of wings. And our obsession in these kind of programs is how can we accelerate the discussions between scientists knowing nothing about a plane and industrial companies knowing nothing about spins and electrons turning in materials. So how can we make the things happen that these partners understand each other and we can really accelerate the process? And in that particular project, we had French and Paris-based scientists. They developed and gave us a lot of inputs how to formulate the coating. And we asked the company who is building the different part of the plane to be part very, very early in the process. And they discussed with us. We went doing the tests on the floor in the industry, because it's not in the lab that you can validate a plane. So you have really to transform that in real products, and then to put it on a real plane. And we were very lucky that we have an airline who was ready to put this coating on a commercial plane. So today there is a plane flying with this coating. So we can not only validate it in a lab scale, but even in real life conditions. And if you have the whole chain from the scientists to the end user in the same project, that is really speeding up the project. And I will close with one comment. That was a process and a project focusing on aircraft. But what we developed there, the knowledge we developed there, we can deliver these things and valorize that in many, many other sectors. And that is something I would like to suggest to the Commission, to think how can we, in projects, which are focusing on one particular sector, how can we use the knowledge we have developed in that, how can we use that very, very quickly in other sectors, avoiding the fact that we restart to redevelop the same things for other sectors. And that is something sometimes I'm missing a bit, to see how can we really profit from successful products and materials in other sectors. Voilà.
Thank you very much, Luc. Very insightful, with, I think, a subliminal or not that subliminal message. The need, indeed, to make sure that dynamics between scientists down to industrial needs are the right ones. And then a very interesting challenge that you put to us to see that solutions found for one industry can spread to others easily. Can I just turn to Sabine and Clivier for anything you would want to add on this first topic?
I mean, with
Sabine
pleasure. I
first,
could go on for a lot of examples, but maybe just two short ones as well, which are part of the Clean Sky 2 project. Here, the multifunctional fuselage demonstrator, where the goal was, and which was delivered, was the first world's largest aircraft fuselage demonstrator with 8 meters length with a thermoplastic composite material. So that's, of course, always going back to weight reduction potential. And the project brought us really a step closer to our common environmental objectives. So here we work with 14 partners, and of course, as you just said before, we are on the part to make it industrially reliable and viable, whereas we need to work with the overall ecosystem to make things work. And just another one in this is the graphene flagship, where we are looking into it's maybe a more systems-oriented thing, where we're looking at graphene-based ice protection systems for very lightweight electrical aircraft, be it on VTOLs or helicopters, where we went from material 1, 2, so that's really very early, into 4, 5 in only 3 years. So these are examples where it's really going into real application and steps forward very quickly. So we are happy to be part of these consortia and the European research conventions.
Thanks very much, Sabine. Clivia?
Yes, I found it fascinating, the actual project content, something that as a scientist I get enthusiastic about all these things, especially when it comes to surfaces and atoms on surfaces and atom scale rugosities and thermal resistances that will increase your kerosene use. But my point here, the point I would like to make is one of how do we keep the knowledge from one project to the next? I noticed in the last frameworks and in the current one that a great deal of emphasis is put in exploitation, and exploitation in a very narrow time scale. And there is very little or no emphasis put on an equivalent plan saying what would be the next step in knowledge that would be required to have solutions, not just technologies, but solutions for similar problems in other areas, much as Luc mentioned here. Last night I was Googling some of the previous, I will reveal my age, SPRI 4 and MEL-ARI, and the Commission database has no memory at all. I could not find anything about those projects, about their final reports, and that worries me because this is really a demonstration of what Luc is mentioning. We are not learning from what we've learned before. And the before is not so long time ago because it has been acknowledged that new knowledge takes 5, 10, 20 years to become to products. And if we delete the information, if we don't consult it, if it is not structured, then it's very difficult to learn from what was exotic or paradigmatically 20 years ago and use it now. Maybe now it's possible with the new techniques, new knowledge, new models we have. Thank you.
Thank you very much, Clivia. Another ball thrown at us, and I'm very pleased about
Sorry.
about that. No, I have already plenty to conclude. But we still have another couple of questions to go through to cover better the different dimensions of the strategy that we have put forward. And in fact, another important objective of that strategy is to develop a strong competitive materials ecosystem in Europe. And to this end, we do need to mobilize many more investments. As today, industrial R&I investments in advanced materials in Europe are in fact less than half of what they are in the United States. Sabine, Airbus obviously is a pioneering company in innovative technologies, and we just heard one or two examples of that already. So the question I would want to put to you is in fact twofold. How do you see the potential of European partnerships as we are approaching them right now with industry, like the one that we now have under preparation for advanced materials? So how good are these to unlock new private investments? And secondly, how do you see the strategy from an industrial point of view?
Yeah, thank you for the question. And indeed, are materials core to the aviation industry's business? Because first of all, we have strong requirements, and we also have in the path towards our sustainability and competitiveness goals a strong need for the materials going on. So we need to closely work together with the partners from the full value chain to remain at the forefront of the latest technology developments and equally ensuring supply. So materials are one pathway for us to meet the environmental and as well performance objectives. So here the close cooperation via stable and secured funding frameworks with a public-private partnership for advanced materials is really important for us to allow to work on a joint strategy and coherence across the sector, and in particular to face the challenges on the materials and processes. So let me give you a couple of kind of directions and comments in which directions we have the challenges. So first of all, we need new performance materials, even lighter systems and structure, resulting in lower fuel consumption, because fuel consumption is kind of the thing which makes 97% of our, let's say, CO2 footprint. So in this regard, we also need new materials for the development of batteries, fuel cells, electronics, so new systems, hydrogen environments. So that is a direct impact of the development of new and next generation aircraft. So these new materials shall be brought into final products. And if we want to achieve that, we need to jointly work on the industrialization processes and the supply chain risks. So here, cooperation is really key. And if we look into the future supply chain, then it is about cooperation and support of the EU Commission that will help us to secure a robust and stable supply chain, able as well to scale up the new materials that are developed. So here, another point I think we should look at is to jointly work on the critical raw materials and the closed loop recycling. And on this one, I think strategic cooperation and the strategy of the industry in cooperation with the partners, we much more need to look at as well at the more circular economy of business. So for the material, that means for us still on the critical material supply, full traceability and transparency of the materials via digital means that can be adopted in the full chain. And here we really have to step up. There's a lot of a gap to be closed. And the joint platform at EU level for data sharing would really ease the traceability and transparency. Just an example, in Germany, we know this kind of platform, which is called Platform Material Digital, which allows the data sharing across the entire country. These are examples, I think, on which we have to build for the European picture as well. And then all this helps to go into the development of recycling technologies for composites. Composites is one of the materials allowing lightweight structure, and the end of life and material reincarnation businesses could contribute to smarter management of our resources within Europe. Then a consequence of the Critical Materials Act is likely that the prices of materials will not only increase, but it will be hard to get them within Europe. So we need to also look into further research to comply with the regulation, but also for alternative materials. So computational materials for me could strengthen the capabilities and competences for material alternatives, as are requested by example for in REACH or with the PFAS. So that's as well an aspect which is for me very important to be covered. And last but not least at all, for me the cooperation remains key. And here as well, the support of the EU. because these challenges an industrial alone cannot at all solve. We need to find the solutions together across the entire process chain. So we know our products very well, but we are not material suppliers or scientific masters. So therefore, we need companies and academia to assess cross-industrially the opportunities to scale up production of new materials. So we need better business models here as well. And you said it, we want to share between industries, because the aviation, in comparison to automotive or construction, is relatively minor customer for material suppliers. So everything we can cross-read, we are really taking it with pleasure. And most importantly, we need to keep the application requirements, cost and scale up in mind. Technology that cannot be matured fast in this constantly changing world will not be able to be industrially adapted, but then likely superseded by other disruptive alternatives. So thank you to the EU Commission for supporting with new instruments, the aviation sector specifically as well, and the broad materials community.
Thank you very much, Sabine. Can I again turn to Clivier and to Luc to...
Okay, so in respect to unlocking private sources of funding vis-a-vis securing public sources of funding, I think we need to look to a value chain or a process development that involves from day one some of the ideas that may be the next generation of the materials that will be found as a solution for this generation material. So it's only having a continuum of ideas that would enable this scouting and preliminary testing ready to step in 5, 10, 15 years when the first solution that is urgently sought after is found, so that we do not have to start reinventing the wheel, building communities de novo, etc. So this calls for a number of factors or properties that must characterize this process. I will refer to them later, but I think it's crucial that we work on the partnership of equals. The only thing that scientists working at the bench or in the low temperature lab or in the synchrotron have in common is a passion for new knowledge, a passion to understand what is nature and how it works. And that passion is way up compared to making things useful for that industry or the other industry, right? So we need to understand that part, what drives scientists, what is the motivation of scientists, right? And I think if you can understand and respect that position and vice versa, I think we could make a long-lasting partnership that will guarantee not a solution for tomorrow, but a string of potential solutions for the day after tomorrow. That's all.
Thank you very much, Clivier. Luc?
Just a short comment. We heard Sabine speaking for a large company, but we should not forget also the SMEs. And especially, I'm thinking about technological platforms, which are key for them to test at an industrial scale new products, new materials. So we should not forget to continue to invest in those existing platforms and maybe creating new platforms so that in this ecosystem you're talking about, also SMEs can find their place with all the tools they need to really speed up the scale up of their needs concerning advanced materials in that case.
Thank you very much, Luc. I'm taking careful notes. I wouldn't want to miss out on these different stimulating suggestions. I would have a last question, returning to the strategy. In there, we point out that there is strong fragmentation of R&I programs at EU and member state level. And this is a problem that needs to be addressed. We call for a better coordination between the Commission, Member States, and key research and industrial stakeholders. So turning now first to you, Clivia, from your experience, what is needed to ensure a dynamic cooperation among all parties to maximize the impact of the decisions taken and investments made?
Okay, well, I'm glad that you posed the question because it's something that working in the lab and talking with people who work in labs, what baffles us is a fragmentation which is not only structural, but it's a fragmentation also in the way we produce and communicate knowledge. So an important factor would be stepping back. This knowledge is generated by humans, so far, okay? And it's very important that we keep our humans, ourselves, motivated, not only for the duration of a 2 or a 3 or a 4 year project, not only until we get the tenure, not only until we move to another country and set up a brand new laboratory. We must be motivated for a lifetime. And we have to pass this motivation to our young colleagues who are coming through the system, because they will generate the knowledge we need for the industries and the materials of the future. The motivation has several aspects, and I'm not at all a psychologist or sociologist or political scientist, but it really needs a level of trust. A trust that this person, this young person, will say, yes, I will dedicate my life to this. Yes, I will commit to this long-term research question. Yes, I am prepared to discuss the knowledge I generate in this travel to answer the research questions with people who can take it up in different areas. Or perhaps I myself will set up my spin-off and take it further down the line of applications. So with this human angle, anthropocentric or otherwise perspectives, we can go back and say, right, is the research we do in Europe at the level of the best possible understanding only in the hands of the European Research Council? Is an individual endeavor? Or is the research we make in Europe requiring also the very basic knowledge at consortium level? Because that has been almost killed. There is very little basic knowledge projects at consortium level funded by public funding. Right. It's only individuals primarily which require a high level of excellence, and I'm delighted that ERC exists. I am myself a beneficiary. But I also think there is value in this consortia approach. The consortia approach has been controversial, from very small projects to very large projects. We had networks of excellence with 70 partners. We have had integrated large projects, etc. And now we're going to pilot lands, which are very, very large projects with companies, SMEs, and academia. And we still have not cracked the nut of unlocking the new knowledge and picking the bits that can be accelerated, because I understand some of the most relevant for industry needs to be accelerated and applied. But if you do not have a pool of ideas and knowledge, it's going to be very hard to identify with long-term impact, like a generation of products, and the next, what needs to be accelerated. So I think that we need a lot of analytical power which can be gained collectively. And this means that small discussion projects like the cost projects are very good, but they do not allow you to the next step to do something together. Yeah. The Ethernet Plus projects are fantastic, but they have a double layer of bureaucracy. So if you're a scientist who is pressed for time, like most scientists are, you say, rather not, right? So what is left is really the main from work program, the pillar 2 and the pillar 3. And then you say, well, but this is not the home for the ideas I would like to develop with my strategic partners from 3 project generations before, which would benefit from the accumulated knowledge that we have gathered since. So, memories of the projects and some continuum. So Sabine mentioned clearly that there are projects that last 4, 5, 7 years, and this is great. I think we need something like this with an administrative dynamics that allows stepping in and allows stepping out, which is another problem when it comes to the poor coordinator who has to deal with amendments and items like that. So I think that simplification, mutual respect, motivation, trust, perspective for the young scientists are key elements if we're going to be working towards harvesting the knowledge that is being produced right now in Europe. Thank you.
Many thanks, Clivia. With an eye on the clock, we are fast running out of time. So I would want to turn to the takeaways, but still I don't want to leave you with the impression that the Commission is pressing our guests like lemons to ask them, what can you do for us? But we certainly do have intentions of rolling up our sleeves ourselves. The first priority for us will be to make this European industrial leadership in advanced materials happen as fast as possible. And the first very concrete step we want to take is to set up the Advanced Materials Technology Council, which would be a forum for a thriving partnership. It will facilitate the coordination among all relevant players, and we will very soon be publishing the call for applications for external stakeholders. So we hope that we will be receiving very many of these. As we are now really at the end of this session, I'm afraid I still had one question, but probably no time for it. So with your permission, I would recap some suggested takeaways here. I think there is a resounding yes on your side for public-private partnerships here as a winning solution, with suggestions to keep in mind SMEs that should also be on board, notably through technological platforms. I also retain in that context that we should be reflecting on the space for consortia-led basic research as part of a better continuum of knowledge development. I retain the need to try to be as sector agnostic as possible in order to speed up scaling up possibilities of solutions, as one individual sector might not offer the scale of demand needed. I retained that we should go beyond the short-term exploitation obsession, and we should improve the Commission's memory, from what I understood, and make generally available results of research endeavors under the framework program much more as a continuum over time, and not lose them after a certain number of years. And finally, this day is very much about green and sustainability. I also retained the topic of critical raw materials, the need to work towards closed loops, the need for that also to have full traceability, and the suggestion to build a European level data platform to ensure that traceability. So thank you very much for this extremely rich exchange. Thank you very much, Clivier. Thank you very much, Sabine. Thank you very much, Luc. And I think they do deserve a very big applause.
Thank you, Luc.
And you might wonder what is in these small boxes. Well, therein you have 5 samples of advanced materials and what they can be used for. And as we are extremely generous, this is not only for our speakers, but there will be also some on offer out there. Don't rush too fast to the exit. Let's keep it orderly. But I think it's something worthwhile looking at to exemplify what I was talking about when I mentioned the magic power of advanced materials.
Exactly. Thank you very much. We'll get one to Sabine as well down in Toulouse. Pick up your box on the way out to the next sessions. The power of knowledge valorization in workshop 1 and innovation ecosystems in workshop number 2. Thank you.